Welcome back, class. I'm getting near the end of this unit, and one of the last topics is infinite solutions and no solutions. And this is definitely something new. I don't believe you talked about this at all before this year. We're going to start, there's just two learning targets today, so you just write them both in the same spot. The first one is I can identify, so this is a lower learning target, a lower level. I can identify when an equation has an infinite or no solutions. And a slightly higher level one, I can explain what it means for there to be infinite or no solutions. So I'll try to help you with both of those as we go through the notes. I want to start, though, with something simple. An equation that you might see on one of the easiest quizzes I could give you. 5x equals 30. So this is an example of the type of equation I would give you leading up to today. And it's a one-stepper. You divide by 5. You get x equals 6. That is the only x that works. 6 is the only thing you can multiply by 5 to get 30. There's no other number. So this is an example of an equation that has one solution. Every single equation I've ever given you this year has had one solution. So one solution is a very normal thing. One solution doesn't have to be a whole number. One solution can be a repeating decimal. It can be a fraction. But it's the only thing that works. So I'm going to give you an example that doesn't work out quite the same. So I want you to try this on your own. I'm going to write it up. I want you to try it. But you're going to have to just pause the video and try it and see if you come up with the same interesting thing that everyone else will. So we'll do this one over here. This is number 1. 4x plus 8 equals 2, parenthesis 2x plus 6. So pause the video, try it yourself. I'm going to go ahead and do it right now. And you see if you come up with something weird. Okay, welcome back. First thing we're going to do is distribute. That's what I would do if I were you. 4x plus 8 equals 4x plus 12. Alright, so we usually get rid of the variable term first. So I say 4x, take away 4x from both sides. And, oh, okay, so this is weird because that went away like I wanted it to, but so doesn't this. And the only thing I'm left with is 8 equals 12. And that is not true. Does that mean I did it wrong? Certainly means I should go back and check my work. 2 times 2, yeah, that's 4. 2 times 6, that's 12. I don't feel like I did anything wrong. And what you have found here is an equation that has no solution, that it's impossible. And you can kind of see, back up in this step right here, if you look at 4x plus 8 equals 4x plus 12. So imagine an x. Imagine what it might be. Let's say it's 1. So 4 times 1 right here would be 4. 4 times 1 right here would be 4. And it doesn't matter what it was. It could be 4, it could be 10, it could be a million. If I add 8 to it, and I also add 12 to it, it can't possibly be the same number. So if you get good at it, you identify the problem right there. But you can always break it down further and see for sure that since this happens, you call it no solution. And that's it. X doesn't equal anything. You can't check it, which is great. Less work, right? There's nothing to check because X is nothing. Alright, that's not the only weird thing that can happen. Right, you could also have this equation. Of course, there's a million different equations that wind up like this, but this is the one I've chosen for you. And I want you to do the same thing. I want you to pause the video and just see what you come up with. Okay, welcome back. Again, let's just attack this like it was a normal equation. No one's going to tell you, hey, this one's going to work out weird. You just have to realize it's going to work out weird. So we distribute, you get 5x plus 5 plus 2x. Write the rest of it. We got like terms on the same side. So let's combine these. We get 7x plus 5 equals 7x plus 5. Very curious. We'll do minus 7x minus 7x. That same thing happens, cancels on both sides. But this time, oops, that's a terrible 5. I get 5 equals 5. This time it's true. It's weird, again, but at least it's true this time. So what the heck does that mean? What it means is, no matter what x I put in, it's going to work every time, no matter what. So we call this infinite solutions. You can kind of see, again, if you go back a step, we look right here. 7x plus 5 equals 7x plus 5. I can't imagine an x that won't work for. You take a number, you do something to it, and you take that same number and you do the exact same thing to it. In this case, multiply by 7 and add 5. Multiply by 7 and add 5. You're going to get the same thing no matter what. So these are the two very interesting equations that you could possibly get, and that's a new 8th grade topic. A lot of times questions will say, tell us if there is one, none, or infinite solutions. So I'm going to pause it real quick. I don't know why I told you I was going to pause it. You don't really need to know that. But it was good timing. The announcements came on. So I want to break down the two parts here. At least get this learning target out of the way, which is I can identify when an equation has infinite or no solutions. So if something's going to have no solutions, it's going to end with two numbers, 3 and 5, that don't equal each other. Could be 10 and 100. Could be anything, but they just won't match. And that makes sense. If it doesn't work, it's no solutions. They kind of go together. On the other side, if something has infinite solutions, they'll end with two numbers that do actually equal each other. So 3 equals 3. 10 equals 10. Now there are other ways this one could end. It could end with x equals x. It could end with 10x equals 10x. Basically, when the two sides are the same. So often you can identify infinite solutions very early on and just say, oh, I'm done, it's infinite. It's got to be infinite. And again, you can't really do a check. You can try, but no matter what you put in, it works. So in a way you can do a check if you wanted to like check 3 and 7 and prove that they both work. So there must be, that doesn't prove infinite, but it does prove that there's more than one. And very likely that means infinite solutions. For the on your own portion, rather than have you do an example, I want to know your thoughts. So I want you to answer these two questions in your notes. What does it mean to have no solutions? What does it mean to have infinite solutions? So if you can answer those questions, and I essentially answered them for you. If you want to go back and listen to me again, watch it through one more time without taking notes, just listen. I basically answered the question for you, but I want it in your words. What does it mean for there to be no solutions? What does it mean for there to have infinite solutions? All right, good luck. That's what we'll be checking. That's what we'll be talking about in class, so don't not have it. All right, under 10 minutes. You're welcome.